So here we have one more polynomial. We're trying to find all the zeros, and they tell us there is a rational zero. So looking at the graph and also thinking about the rational zeros theorem, I could have factors of 5 over factors of 3. So 1 over 1, 5 over 1. I could have 1 over 3. So try those in your calculator on the graph and look at it and see which one is a zero. You can always try process of elimination using synthetic division, but it's definitely easier to just look at the graph and try to make sure that the one you're going to use actually works. So when we look at the graph, it looks like there's a 0 at 1/3. So I'll try that one with synthetic division first and see if it works. So add, multiply is 1, add gives you -3, multiply gives you -1, right? 3's cancel. This gives me 15, and 15 over 3 reduces to 5. So I get a remainder of 0, which shows me that that was a 0. So why is that useful? Because if I just took out this factor that goes along with 1/3 being a 0, I'm left with 3x squared minus 3x plus 15. And so now I have it down to something that's quadratic. If it's quadratic, I can try factoring, or even if that doesn't work, I can always try quadratic formula. Always gives me a solution to a quadratic. So if you can get it to divide 1 or 2 zeros out, when you make it to quadratic, you're kind of home free. All right, I notice all these are divisible by 3, so I might also pull a 3 out. Makes it easier to see if it factors or not. So yeah, nothing multiplies to 5 adds to -1, so I'm going to have to use quadratic formula. But even pulling a 3 out now makes my quadratic formula number smaller. A is 1, B is -1, and C is 5. So -1, the negatives cancel. The -1 squared is 1 for B squared, minus 4, A is 1, and C is 5. And then all over 2A, which is 2 times 1. So this is 1 minus 20, so -19. Well, what do I do when I have negative square roots? How do I deal with that? I can pull out the I, and then square root of 19 doesn't reduce anymore. So that's about as simple as I can get that. If you want to write it as a complex number with a real and imaginary part separate, you can put 1/2 plus square root of 19 over 2, but I don't think I should be picky about whether or not you put the whole thing over 2 or not. So there we had one rational zero and 2 complex or imaginary ones.